Hi everyone, welcome back to our channel. So this is Asim here, and for those of you who don't know me, I am a security engineer at Grofers. I make videos on cybersecurity. It could be related to web app security and even hardware security. So I post videos every week. So if you haven't already subscribed, make sure to subscribe and press the bell icon so that you don't miss a video from me. Another announcement, there's going to be a live stream this Saturday at 10 a.m. IST. So I'm planning to do a 2 hour long live stream, but like last time, it might get extended. So the first hour, we would be focusing on solving some of the XSS challenges from PortSwigger Labs, and also there's another website. So I'll be talking about that as well. And yeah, so there's a question link. So if you have any questions or you want me to answer any questions, so the later half would be the Q&A session. So you could submit your questions through the form link, so that if there's something that I'm not prepared, I could be prepared about it. Or you could ask impromptu as well. You could comment in the chat, or there would be a live chat, so you could comment there as well. So that's that. Like recently, a lot of people have been asking me about how to get a cybersecurity job as a fresher. So that might be a question that you might want to get answer to. Like I have also been a fresher and this is my first job. So I'm kind of eligible for answering that. So yeah, that's about it. Also, thanks a lot. So the last video was received quite well. And if I see the start on my like YouTube studio, so it's on the top, and I think people liked it. There were a lot of likes, and if you like these kinds of content, so make sure you share this with other people as well. Like the video and subscribe to the channel. So that's all. Let's start with the video for today. So today we're going to talk about DOM Clobbering. So in the last video, you would have seen that we solved the XSS bug POC challenge. So one of the part was the related to DOM Clobbering. So I couldn't get into the lot of details about it because it was already a very long video. So yeah, so I thought there should be a dedicated video to DOM Clobbering because it's again in itself it's a very like a good kind of attack vector. Most of the people don't look at it. So there's this overview. So what is an XSS, types of XSS, XSS still relevant. So these are all the almost same as the previous video. So if you have seen all these, like if you have seen the previous video, you could skip to the part where I discuss what is a DOM. That's relevant because a lot of people, they know how to attack XSS, but they don't actually know what is a DOM, and that's important when you understand what is a DOM clobbering attack. So yeah, I would add the timestamps. You could straight away go to that. And then we would be solving a PortSwigger Lab challenge related to DOM clobbering. And later on, we would be seeing a report that was XSS in Gmail that was reported last year in August. So that's a very good, like a well-written write-up. And the like I got to know a few things from that, like why do we use anchor tags only and why not other tags to clobber the DOM. Like in the XSS bug POC challenge, I used the input tag to clobber DOM, and that worked there because of a particular condition that was being met there. But in most of the cases, you would have to use anchor tag, and that answer I didn't get in the PortSwigger's DOM clobbering article. When I read this XSS in Gmail article, the researcher had done their part, and that was quite good. And there I got to know about why anchor tags are only used and why not other tags. So yeah, so what is an XSS? So as you could see the diagram on the left side, so XSS stands for cross-site scripting. So here what happens, hacker injects a JavaScript, a malicious JavaScript onto a trusted website. And when the victim visits that website, they get like the malicious code gets executed in their browser in the user's context. So any malicious thing, maybe stealing of cookies or accessing the web camera, so those could be done using the malicious JavaScript. So that's XSS. So it was first coined by Microsoft developers in the year 2000. So it's almost 2 decades, and this attack is still prevalent, very prevalent, I would say. So potential impacts of XSS, if you ask, so it has quite a huge attack surface. Like anything that a person can do in his browser, this JavaScript could be able to do that. If the cookies are there and if there's a session cookie, those session cookies could also be stolen, and basically the attacker could do a remote session takeover. The only protection there is it's about HTTP only flag that's being set on the cookie. So if the flag is set, then the browser won't allow JavaScript to access that cookie. And because HTTP only instructs the browser that this cookie should only be sent in the HTTP request and not be able to access by the JavaScript on the page. So XSS, like the attack is limited there. The JavaScript could view anything the user sees. It could steal any sensitive information on the page itself. The JavaScript, the malicious JavaScript, could steal the user and manipulate like information on the page. It could bypass any of the CSIF protection because, as I said, it could steal anything. So it could steal the CSIF tokens and make a request on behalf of the user to submit the form automatically. So basically, it could bypass all the CSIF protections because the only check that's there for CSIF protection is a random string which is called nonce, and that's embedded onto the HTML of the page. So since the JavaScript could access the DOM, so the HTML, so they could also access the nonce of the like CSIF protection there. As I already talked that if the web page is accessing your webcam or microphone, like suppose there's an XSS on Zoom's page or maybe Google Hangout page, so the JavaScript could also access the webcam or microphone if you have already allowed it. Now let's see what are the different types of XSS. So the first type is stored XSS, also known as persistent XSS, and it's more like dangerous than non-stored. And this is the kind of XSS that we are going to see in this lab. So this occurs when the user input is stored on the target server. So storing user input could be in the form of like say comments or maybe posts. So suppose if there's an XSS on Facebook, so that could be a stored thing. Like suppose there's the XSS is being executed in the post. So if you create a post, that post remains on your profile or on your timeline. So anyone who goes and visits your profile, so they would be a victim of that XSS because it's a stored one. Then the second one is the reflected XSS or non-persistent. So here the payload that you have entered that gets reflected on the page itself. Like suppose you are doing a Google search query. So that search query gets reflected on the page. So if Google was vulnerable to XSS attacks and if your payload was reflected on the page, so that would be a reflected XSS. So for that, you would have to send the URL to the victim, and it wasn't a stored thing because if only the people who visit that URL with your payload, so only those would get affected with this XSS. Then there's this third type that's a DOM based XSS. So here the tainted data flows from source to sink on the same page, and it's a subset of a client side XSS. If you ask me, is XSS still relevant? It's a big yes. And if you see the HackerOne reports, it was the highest like awarded vulnerability of the year 2020. Around $4.2 million was awarded for this. It rose 26% from the previous year. And if you see in Facebook itself, so in the past 6 months there have been two major XSS attack vector on Facebook. The first one was the 20K Facebook DOM XSS, and the second one was a $25K. That was similar to what was shown in the previous video. Now this is fairly new content for this. So if you have already watched it, you could continue from here. So what is a DOM? So if you see on the right, there's this document thing, and everything beneath it, it's the HTML page content. So the root element is HTML. So if you would have seen any of the web pages, so there's this root element that's HTML, and every other thing is encompassed into the between the HTML opening and closing tags. So there's this head element, there's a body element. Inside head, there's this title tag, meta tag, script tags, all those things. So basically, that's a part of the document, and DOM stands for Document Object Model. So here goes the standard definition. And in short, if you would like to understand, so HTML DOM is a standard that allows you to access these content and play with it, maybe manipulate it or get it or update it, anything. This is a screenshot of me showing or highlighting the document. So if you go to your console right now and if you type document, so the whole page would get highlighted because document is the root of all these. Now let's talk about how or what are the conditions of DOM clobbering. So if these particular conditions meet, only then there is a DOM clobbering possible. So the first condition is insert HTML with ID or name attributes. So if you have control over what the HTML you are able to insert, and if you are able to insert it with ID or name attributes, then you would be able to, like, the first condition would be met. Then there is the second condition that there should be a global variable, because that global variable is what we are going to clobber. So it could be a property of an object, usually a window. And then on the left, there is this screenshot from PortSwigger's DOM Clobbering article. So here, if you see, there's on the first line, they mention that there's a common pattern used by JavaScript developers. That is, there's a variable var some object equal to window.sum object. Then there's piping symbol. Then there's a empty object. So if there's a curly braces opening and closing, and there's nothing into that, so that's a empty object. So if there's something into it, then that's a object. So it basically, this line means that there's this variable that's being defined, some object, and that is equal to either the global variable window.sum object, or it's an empty object. And the way it's being used in the script, so it's mentioned below that. So there's this window.onload. So window.onload is a function or a event handler. So that means that whenever the window gets loaded, window.onload, so whenever that gets loaded, this function should get executed. And if you see the function there, they have used this sum object. So they have defined that let sum object equal to window.sum object, or an empty object. Then there's this let script equal to document.createElement script, and the script source is some object.url, and then they are inserting this script into the body. So document.body.append script. So to exploit this vulnerable code, you could inject the following HTML to clobber the some object reference with an anchor element. So there, here, like, we have used anchor tags, two anchor tags. Both have the same ID as the global object, the some object thing. And then in the second anchor tag, you could see that there's this name parameter or name attribute, which is the same, like the value is same URL as it is used here, that some object.url. And then the href is the malicious JS file. So you could see the similarity among the two. If I talk about the conditions, so you could see the anchor tag had ID and name. So the attacker was able to insert that. So the first condition is being met. The second condition was there should be a global variable that we have to clobber. And here we saw that there was a some object global variable. So window.sum object that was being assigned to another variable. So we clobbered that global variable. Now let's come to the lab. So here this is lab exploiting DOM clobbering to enable XSS. The lab contains a DOM clobbering vulnerability. The comment functionality allows safe HTML. To solve this lab, you have to construct an HTML injection that clobbers a variable to execute the XSS. Let's access the lab. I prefer to keep the lab description open. So yeah, that's that. So this is the blog post, and it mentioned that in the comment section of the blog post, there was something like you could post safe HTML there. So let's look at one of the posts. The first thing that you notice, this post ID equal to 2. It's not particularly relevant for this XSS, but I'm just curious. So like, I tend to have some of things noticed right now. So let's check the source first. So Control U. Here in the top, you could see there are some CSS files. Then there's this JS file, that's labheader.js. And like, I've already read it, and it basically changes the status of this solved and not solved thing. So like, currently you could see that it's not solved. So that this JS file is responsible for setting that header. Now let's see, there's this div ID. So back to lab home, DOM clobbering enable XSS. So this is here, DOM clobbering enable XSS, the h2 tag. Then lab not solved is there. Then there's this image, this smart recognition h1 tag. It's here, h1 tag. Now let's see. So here's the comments. So if we see the comments, so this is the h1 tag for comments. And then there's this span. and then there's HR is for horizontal rule, so this should be the horizontal rule. So this is the horizontal rule, this just above the leave a comment thing. So we see that in the comment section there are not actual comments, rather only these files are there. And then there's the span ID user comments. So whenever you find something that if it's not in the source, so like if the things that are present on the HTML page, they are not in the source of the code, so the next thing you should do is you should check the developer console, like Control Shift I, and just press on this and go to this. So if you would find it here. So probably what would have happened is that any like there would have gone a network call which would have fetched the comments and inserted it into that. My guess is that in this user comment span it has been inserted, which I also verified after looking at the JS files. Now there's this leave a comment thing. So that's this leave a comment. Then there's this form here. So we have understood the basic structure of what the HTML says. There are two things. This is DOM purify JS file, and then this load comments with DOM clobbering.js. So DOM purify is a standard library. So you could check it out here, Cure53. So it's basically used to sanitize the HTML output, as you could see it here. It helps prevent XSS attacks. There are a few vectors that it doesn't sanitize or probably kind of bypass for this particular thing. So I didn't know it earlier. I came to know after reading the solution here. So just just a like information disclosure that even I didn't know this. So that's another thing. Let's come back to this. So there's this DOM Purify version 2.0.15.js. So there are like bypassers available for this, and those have been assigned CVs for that. So you could look for that as well. Then there's this DOM Clobbering.js. So let me show you in the debugger menu, like in the developer console. There it would be better to see. Reveal in sources panel. Click it here. It's expanded. So the very start of this, you could see that there's a like network call. There's a get request being sent to this slash post slash comment, and then in that response, this dot response dot text. So the response is the comments, and this comments is being passed to display comments. So if we go down here, this is the display comments function. Document dot get element by ID user comment. So basically, it's being used to fetch that element. So if we do this, we get the span ID, right? Where a equal to a, and you could see that a is the span where the all the like comments are being posted. Let's come back to the code. So here there's a loop. So this loop basically iterates over all the comments that have been fetched using the XHR request. And then there's this element create element section, which you could see here. So these are all sections. So this is one section, class equal to comment, and that's being like populated from here. The attribute is set to comment. And so each comment is a section which has the class comment. Inside there, there's the first paragraph element. Then there's this default avatar. So here you could see window.default avatar, or there's this object avatar which value is this. So this is the global object that I was talking about. So this is the second condition that is being met, that there should be a global object. So we would be clobbering default avatar. And as far as HTML goes, it's already written here that HTML is allowed. So let's start with constructing the payload. So the payload would be a id equal to default avatar. Let's close this. Another tag id equal to default avatar, and the name should be like the value that you are trying to clobber. So here avatar is the value that we are trying to clobber. So name equal to avatar, href equal to, so cid colon, instead of colon you have to write like you would write like this code. Then you would write on error equal to alert 1. Then you could close this. So what it essentially translates is to, so when window dot like default avatar would be selected, so this value would be selected, like these would be the values. And when that particular function tries to access the avatar thing, so like in this next line, if you see here on the right, so let me, okay, so if you see in the next line, so comment dot avatar, so image class avatar src equal to this, and this whole line is being pasted. So if I show you here, let me clear this. So image src equal to either comment.avatar or escape html comment.avatar, or if this is not if this is not there, then it would be fetching default avatar.avatar. So when it's trying to fetch that, it would be getting this value, so like the cid value. So here, instead of this, what it would be, image src, let's remove this, and ampersand quot is basically URL encoded for the double quote. So this would be the final image class. So we could see the XSS here, that src is a random SR source. It's not a valid source. So there would be a on error call to the on error event handler, and that would create the alert here. So what do you expect? So just pause the video here. What do you expect? That would it be executed on the very first time that we are trying to execute? Like I just submit it and come back to the page and there would be alert payload. You should pause the video for a moment and think whether that would be executed or not. I would be showing as to whether it would be executed or not, but think for a moment whether it would be executed or not. Let's enter any name, gmail.com website, https google.com, post a comment. Thank you for your comment. So now when we go back to the blog, the comment is already stored there, so there should be stored XSS, right? So we should see an alert popping up here. There wasn't any alert, and that's because, so see, the first time this comment is being posted here, now the element has been clobbered, but as I showed you the loop here, the for loop. So what happened is, so once that comment was reached, this our clobbered comment, so this window.default avatar value was clobbered. But since there is no further comments after that, so that value is not being used here. So if I just create another random comment here with any value, so what would happen is, this time, like when the loop is iterating, so in this earlier comment, this clobbered comment, the window.default avatar value has been set. So when the next comment is being rendered, it would have that image src equal to cid, on error equal to alert. So if I go this, and if I go back to the blog, this time we should see an alert here. So you could see alert 1. Probably you would have understood it. Let's evaluate it again. So let's inspect this. So you could see image src cid, on error equal to alert, as I showed you, the same way it's there. Oh, yeah. So we use cid ampersand quote. We use that because DOM purify, otherwise it sanitizes all other inputs. Only cid is there, and I came to know after I read the solution. I didn't know it earlier. So that's the DOM clobbering thing, and how you could solve it, and why it was there. Now let's talk about why we are using ampersand, why we are using anchor tag only. So let's come to this write-up. So there was this XSS in Gmail, AMP for email. So AMP for email is basically sending interactive emails. So if you are on Facebook and if you are getting emails for the notifications, so you could see that in the email there's this number of notifications, there's a badge there. Or if you are using Google Calendar, Google Drive, or Google Forms, so in through the email itself you could submit the, you could accept the calendar invite, or you could write a comment in the Google Drive. Or if you are doing a LinkedIn thing, so if once you get the LinkedIn notification mail, so you get the number of badges, number of notification badge there. So those are all interactive content, and the JavaScript is being executed there. So that's possible because of this AMP for email thing. So this researcher, he found a bug in that in August 2019, and this is the whole process. So I would urge you, even after the video, go and read this blog. It's very informative. So you mentioned that there's this amp.gmail.dev playground where you could enter your HTML formatted email, and it would say how that would be rendered on the HTML in the email. So for that, they have made a playground where you could test all these. So he tried to insert the very first thing, script alert, and obviously that wasn't allowed. Custom JavaScript is not allowed. When playing around with that, he tried to find like bypasses for it, and he noticed that ID attribute was not like disallowed. So basically it was allowed in the tags. So the first thing that should click you, and this is the first prerequisite, that ID name tag name attribute should be allowed. So he figured that okay, ID tag was allowed. So now he started looking for DOM clobbering. So he mentions that it's a legacy feature of web browsers that just keeps causing trouble. So legacy way is to access any property via global thing is the via the global object like window.sum object. So what happened with window.sum object was it clobbered the actual value and got the value from the anchor tag. Like in our case here. So what happened when you try to get window dot default avatar, default avatar. So you get a HTML collection, and once you try it avatar, so you get this ahref ID. So that's what he's talking about here, that this is the legacy function through which you could, like using window object, you could access the direct element. Otherwise, the actual way to access this is document dot get element by ID, and then you would have written here default avatar. So here you would get like the first thing, and if you want like get all those, so ID should be unique. So that's why we are getting only one of the element. So yeah, let's come back to this. So he says that that's a legacy way to access global objects using the global window object. So window.username is in this case exactly the same as document.get element by ID and bracket like single quote username. So for further analysis of DOM clobbering, suppose we have a following JavaScript code. This is the JavaScript code window.test1.test2, and then it is being passed to eval function. So, and our job is to evaluate arbitrary JS code using only to solve this task. We need to find solution to two problems. First thing is, can we create new properties on window, but can we create new properties on other objects? Like in this case, it was test1.test2. So we're not directly creating object on window, like in window global object. Rather, we are creating object on window.test1. So test2 is a sub object of test1. So that's the first problem. Second thing is, can we control how our DOM elements are casted to a string? Most HTML elements, when casted to a string, return similar thing to like this is the thing or this is the string that you would return, you would get instead of getting like the actual value. So let's begin with the first problem. So he mentioned that if you are using a form tag and inside that you have a input element with the name, whatever the name it is, so if you use test1 as the ID of the form and then test2 as the name in parameter of the input, so you would be able to access window.test1.test2. So you would be able to access the input element inside the form. So that way you could easily understand that any amount of nested thing could be inserted into the form elements, and you could easily access those or create that chain using this form tag. Now we have to solve the second problem. So the first problem is solved, and once you do this alert thing here, so it alerts object HTML element. So input element. So that doesn't like alert a string as we saw in this case. Like in our DOM clobbering, we alerted a one. So this problem is being solved using the anchor tag, and that's why we have used the anchor tag. So here we mentioned that I've created, so this instead of printing the string, this object thing is being printed because the toString method inherits from object.prototype or is defined in another way. So if they don't inherit from object.prototype, then probably something else than this would be returned. So there is a global object, and if this particular two, so there is a method called toString on each of these JavaScript objects. So that basically gets the string representation of whatever you're trying to print. So if you do a console log and console.log and bracket whatever element you try to print, so basically the toString method of that particular object is being called, and that is being printed out there. So like he wrote a small code to figure out in what of the cases there wasn't any object element printed. Instead of that, there was a string thing printed. So he found that there are two elements. There's this area element, and then there's this HTML anchor element. The first one is disallowed in AMP4 email, so he only considered the second one. In case of anchor element, toString returns just a value of the href attribute. So if we go here and if we say dot to string, oh sorry, we had to write here. So this dot to string. So we get the href value, you could see here. So that's what he was talking about, that if, and that's why we had a payload in the href value. Let me close these. So he found that, okay, a id equal to test1 dot test1 href equal to whatever the url was there. So now when you do alert test1, it would alert the href value. At this point, it may seem that if we want to solve the original value problem, we evaluate window.test1.test2 using. So here you might think that, okay, we would insert this anchor tag into the form element, and because then we could nest the elements. But that's not possible, because if you do like that, it doesn't work at all. Like test1.test2 would be undefined. So if you have a form element and inside that you have an anchor tag, you won't be able to access that using the earlier method, that window.test1.test2. So you would have to only have an input element, but then that would again create a problem, because the toString method won't be printing out the actual string, rather the object representation of that. So there you found a solution that you could have two elements with the same ID. So in that case, you would get a HTML collection similar to what we got here. So we had two elements with the same ID. So this is the two elements. So HTML collection, this is what we got here, HTML collection 2. And now the specifically particularly interesting thing that he talks about is that if you have the second element which has the same ID and you define a name attribute onto that, so that way you could like go deeper into the exploit chain, like window.test1, and whatever the name value is there, you could access that particular element using that name value. So like if you wanted to access the second element of it, so the usual way would be like this array thing. But if, since we have defined a name attribute to it, so even passing the name attribute would give access to that particular anchor tag. So that's what he's talking about here, that enter two anchor tags with the same ID attribute, and whatever you want, the nested thing, you just pass on the name of that nested thing as the name value to the second anchor tag. So that's why I had given name equal to test2 to the second anchor tag. So that way they could access that. So the second condition for DOM clobbering is to find a global object. So he found a DOM clobbering in M4 email. So he tried to look for the global objects. So if you just press window and window dot, and you could see all the global objects here that's accessible from window. So most of these are like um, default objects, or like those cannot be overwritten, but there are some that you need to figure out, and those could be the values that you could overwrite. Like these are on blur, and these are all like event handlers, so you cannot overwrite those. So he tried looking at the global objects, and the first global object that he found was the AMP variable. So he tried clobbering that, but it was like restricted. There were some checks to avoid DOM clobbering. But then there was again another variable, AMP underscore mode, that wasn't restricted. And once he clobbered that, he found that there was this error in the console which mentioned that undefined. So this URL was there and there was this undefined thing. And it quickly struck him that this undefined was coming because he was clobbering that value. So he figured out the JS code and he like spent some time with it, and then he figured out that he could control the whole value of this JavaScript file. So basically exploiting creating XSS there. He tried that, but eventually he found that like he couldn't bypass the CSP. But in Google's bug bounty program, anyway, you would get the full bounty even if you couldn't bypass the CSP. So that's how he got the full bounty for this XSS on Gmail. So that was that. Make sure you go and read the article. It's quite an informative one. So yeah, hope you like the video. If you like it, share it with other people and subscribe to our channel. Like the video. Thanks a lot. Make sure you join the live stream this Saturday, 10 a.m. IST.